Hello, sixth grade cowboys and cowgirls. This is lesson 2.3 on comparing and ordering rational numbers. So, first we're going to look at equivalent fractions and decimals. Let's complete the number line by writing the missing decimals or fractions. Well, we know that 1/10 written as a decimal is 0.1. 2/10 is a decimal. 2/10 again is 2 over 10, or if you simplify, 1/5. Then you have 1/2, which is a decimal, is 5/10. And 7/10 again as a fraction, 7/10 would be 7 over 10. 4/5 is 8/10, which if you didn't know, there's a couple ways to find that. If you take 4/5 equals something over 10, you know that 5 times 2 is 10, therefore 4 times 2 is 8. So 8/10 is the same as 4/5. Also, another way to do it is top dog it or divide it. 4 divided by 5 gives you 8/10. So there's a couple of ways to find or convert fraction to a decimal. It says use the number line to find a fraction that is equivalent to 25/100. 25/100, when you divide them both by 25, you get 1/4, which shows 25/100 is here, which again is 1/4. Explain how to use the number line to find a decimal equivalent to 1 7/10. Well, 7/10 as a decimal is 0.7, so you just put the whole number in front. You really don't need a number line, so 1 7/10. So moving on, it says use the number line to complete each statement. Well, we know that 2/10 is 2 over 10. If you simplify it, you get 1/5. 3/10 is 3 over 10. 75/100 is 75 over 100, but you can simplify that to 3/4. 1 25/100 would be 1 25 over 100, but 25 over 100 we know simplifies to 1/4, so that would be 1 1/4. So skipping down here, it says name a decimal between 4/10 and 5/10. Well, if you have to actually put a 0 behind the 4 and the 5 to make it 40/100 and 50/100. In order to get a number in between, you notice that 45/100 is halfway between 40 and 50. So 45/100 is between 4/10 and 5/10. Okay. Let's talk about ordering fractions and decimals. So example 1 says you have 2/10, 3/4, 8/10, 1/2, 1/4, and 4/10. You want to order those from least to greatest. Again, the easiest way to do that would be convert them all to decimals. We know that 1/4 is 25.25 or 25/100. 1/2 is 5/10, and 3/4 is 75/100. So now it says use the number line to write the decimals in order. So if you plot them all on the number line, and then the least to greatest is in this direction, so you're going to start far left. So 2/10 would be first, which is less than 25/100, which is less than 4/10, which is less than 5/10, which is less than 75/100, which is less than 8/10. So now in order from least to greatest, if you put them back in original order, which you usually have to do, so make sure you do that, it's 2/10, 1/4, 4/10, 1/2, 3/4, and 8/10. That's in order from least to greatest. So if we want to order 1/12, 2/3, and 35/100 from least to greatest, it says write the decimal as an equivalent fraction. So in this case, you may want to go fraction. So 35/100 is 35 over 100, which simplifies to 7 over 20. But if you do this, you have to find common denominators. So 1/12 is 5 over 60, 2/3 is 40 over 60, 7/20 is 21 over 60. And this is how you would convert it to all of them having the same or common denominator. This is order fractions with common denominators by comparing the numerators. So again, once you have all common denominators, all you got to do is compare the numerators and put them in order. In this case, least to greatest would be 5 is less than 21, which is less than 40. So this would be first, followed by this, followed by this. So 5 over 60, back in original form, 5/60, which is 1/12, 21 over 60, which is 35/100, and 40 over 60, which is 2/3. So this is in order from least to greatest. So an example, if you want to order these fractions and decimals from least to greatest, I would convert these to decimals. 3/5 is the same as 6/10. 7/10 is written as a decimal as 7/10, like that. So now if you want to order them from least to greatest, we'll do it down here first and then put them back in original form. So always compare left to right when you're going from least to greatest or greatest to least. So the ones place, they all have zeros. So going to the tenths, you got an 8, a 6, a 1, and a 7. So obviously the 1 is the smallest, followed by the 6, followed by the 7, followed by the 8. So this is in order from least to greatest, but back in original form. Okay, this is 1500ths. The 6/10 was 3/5. And 7/10 was 7/10, and then 8500. So this is in original form in order from least to greatest. All right. It says 5 friends completed a triathlon. Whoops, there we go. 5 friends completed a triathlon that included a 3-mile run, a 12-mile bike ride, and a half-mile swim. To compare their running times, they created a table that shows the difference between each person's time and the average time, with negative numbers representing times less than the average. Okay, they want to order these numbers from greatest to least. Now make sure you pay attention when it says least to greatest or greatest to least. In this case, greatest to least, they're going to go to the largest number to the smallest. So if we convert 1/2 to 5/10, convert a -1 1/4 to a -1.25 or -21 2500ths. Now we can just compare them straight out. Use the number line, so if you put them all on the number line, we know that greatest number, remember you're going greatest to least, so you're going this direction now, so you're starting to the far right. So 1 and 9500ths is greater than 1 and 4/10, which is greater than 5/10, which is greater than 1 and -1 and 2500ths, which again is greater than -2. So the numbers in order from greatest to least are listed here. So let's go down to the bottom. It says to compare their bike times, the friends created a table that shows the difference between each person's time and the average bike time. Order the bike times from least to greatest. So let's convert. So 1 and 2/5. See, 2/5 would be 1.4. 1 and 9/10 would be 1.9. So in order from least to greatest, remember the more negative it is, the smaller it is. So -1 and 8/10 would be first, followed by -1 and 2500ths, followed by 1, followed by, well, 1.4 is smaller than 1.9, so 1.4 is 1 and 2/5. And last is 1 and 9/10. So least to greatest. All right, we're going to do some of these examples, not all of them, just do a few. So let's see, why don't we just